When I look at these pipings, I think that's more like temperature regulation, where we come to a very big point because this is temperature dependent. Here you see the end plates and you see many ports in the parallel cell. So maybe, I don't know how many cells this might be, but some of these ports can be for cooling, and some of these ports can be like pressure relief valves, so you cannot ruin the membrane, and some are. When you look here, some are the output ports. So here you have a very strange design where you got 900 bar, 50 square centimeters. That's twice the size of the VOLKS electrolyzer. VOLKS electrolyzer is 28 square centimeters. So now the water, so it's kind of a problem, because in this process basically we wouldn't have any water if we do not put in water, or we have very moist hydrogen. So that's why I like the idea of having the electrolyzer here, getting the moist hydrogen and water in here, having maybe a recirculation, and there will be hopefully some diffusion. So if you put the water trap, for instance, a little higher, you will even have a float. So I read different stuff. So you can float the anode, you can fill this with water, and the hydrogen will just bubble through this side, which is obviously possible, but then you have very, very, very much water in the high pressure gas. So yeah, I rather like this design, putting the float ball valve a little higher, that maybe you have it flooded until here, you get the most moist hydrogen in, the membrane is wet. Yeah, and from time to time you purge a little water, which you can then put back into your electrolysis, right? I show you some designs. So I think these are like museum designs. Nobody would build a real machine like that, but if you enjoy it, you can do it.